So hello guys, welcome back to my channel Code Shiba, where I'll be posting DSA or leetcode solutions each and every day, and today is day 8th of doing so. The problem in front of us today is find minimum in rotated sorted array, which is leetcode problem number 153. Okay, so let's directly jump into the problem and see what it is. Now the problem states that we will be given with an array which is rotated and sorted like this, and we need to find the minimum element within this array. All the given elements in the array are unique, and we need to write an algorithm which runs in big O of log n time. Okay, so this is everything that we need to know, and let's discuss this problem in detail by taking an example. Okay, so 1 2 3 4 5 6. So within this problem I need to find the minimum element. Within this array I need to find the minimum element, right? How can we do so? The very first approach to this problem is linear search. But is it the most optimal approach? Clearly no, because the time complexity, if we iterate throughout the array, would take us big of n time complexity, which isn't that we want, or which isn't, and this isn't asked within the question. The question tells us to solve this problem within big of log n period of time. Therefore, the best way to solve this problem is through binary search. Binary search, because the array is sorted, and also like searching is involved. So what kind of an algorithm we use in an array which is sorted for searching? It's clearly binary search. Now since we already know about how basically binary search works, we need to find how we can find the minimum element through binary search within this rotated sorted array. So to do that, let's first have our basic 3 pointers into their position. We will have a low, we will have our high, and we have our mid at its place, right? So to solve this problem, what we need to do is we need to break down this array into halves. In every binary search solution, we break the array into halves until we reach a particular solution, right? So within this problem we will do the same. We have to find a logic through which we can break down this array into half. So the first thing to notice here is that we need to find sorted and unsorted half. So the thing is that within this array, if it was sorted and the initial composition of this array was like sorted in this order, if you make a graph, this array would have elements like this, not necessarily like this, but it was increasing in order. That's what I'm trying to tell you. So if this array was increasing in order, so if it was to be rotated a certain number of times, then there should be only one pivot point. What I mean to say by pivot point is that if you make a graph again after rotating this element, like n times, we will roughly get something like maybe this, or maybe I don't know, this. What I'm trying to tell you is that there will always be the minimum element within the array. and that minimum element is the point where the array is sorted. So if we know, like at this array the minimum point is 1, and from this point the array is sorted. So if we kind of make a graph of this array, the kind of a graph that I can make with this array is like this. I can make it like 3 4 3 4 5 will go ahead, and 6, and then suddenly there is a drop. We will go here, and then a 2. So this is the pivot point within this array. Okay, then it's fine. So we need to figure out the sorted and unsorted half within this problem. If we can get the sorted half, it is very easy to find its lowest. So the initial arrangement for a binary search is like low will always be smaller than equal to mid, and mid will always be smaller than or equal to high. If even half of it is true, if I say low is smaller than or equal to mid, that means the left part is sorted. Or if I say that mid is smaller than or equal to high, that means right half of the array is sorted. Right? So if we can observe clearly within this array, the left half is sorted. If the left half of this array is sorted, we can definitely say that, like, we can definitely say that the minimum element within the array is to be found within the sorted half is to be found at low, ARR of low. We will find the minimum element at ARR of low if it is left sorted half. But if the right half is sorted, but if the right half of the array is sorted, then minimum element would be ARR of min. If we have this part as sorted, we will take low. But if we have the right hand side of the array or the mid as sorted, then we will take mid as the minimum number, mid as the minimum number or as the minimum element. So if we just follow this strategy and break down our array into halves again and again and again, so again and again and again, then we will definitely update min to its least possible value. How so? Let's have a dry run of this problem. Okay, so if let's say this is the sorted half of this array, what are we gonna do is we will take this as min. Min will be updated to 3, and then we will take our low and we will place it at mid plus 1. Low will be here, high is here, our mid will be here. And now as we can see within this problem, low is greater than mid, so this is unsorted half. Low is greater, or another way to phrase it is our low smaller than or equal to mid? We will say no, our low is not smaller than or equal to mid. Is our high greater than or equal to mid? Yes, our high, which is 2, and it is greater than or equal to 1. So it is true. Since our right hand side is sorted at this point, we will take minimum as mid, and if we compare it to the previous value of mid, which was 3, we will definitely update our minimum element, which would then be 1. And finally, after having this after like doing everything like this, we will update our high to mid minus 1. And what happens then is we will have all of the three pointers at 6. At 6 we will have low, high and mid, but at this point 6 is not smaller than, we cannot update 6 with minimum element within this array, so we will not use this value. And after this iteration, left will go towards the right, and our binary search condition will terminate. So now let's try to implement this problem. Since now we have discussed on how we since now we have discussed the logic of this problem. Okay, so let's get started. We can take res initially as int max. If right half of the array is sorted, then we take mid value. So I guess this is fine. It should be mid. Let's check if my code has any errors or something like that. So yes, my code works for these test cases, but now let's submit this and see if it works for large test cases too. So yes, my code is fine. So this is the final code. Thank you guys for watching my video, and thank you for supporting me. It means a lot. And okay, bye, see you guys again.